I rasa dia akan automatically record. Okay, tapi I start juga lah record. Okay, alright. Okay. Alright, so okay, so this is the new topic for the chapter number 3, Introduction to Chemical Reactor Design. Okay, okay, so this is the lecture online. You need to learn about the relation between the concentration and the conversion, which is the C and also the X. Alright, and then you need to know how to tabulate certain information into the stoichiometric table. Okay?
Doktor,
Ya.
doktor ada share ke screen?
Ada. Oh, kenapa dia tak muncul
Tak
dia?
ada.
Ya Allah, itu.
Ada, doktor.
Okay, sorry. Okay, sorry Nah. Sat Nah. Okay. Okay, nampak ke? Syok sendiri je saya ni. Okay.
Okey,
doktor.
nampak dah sekarang.
Okay. Sat Nah, saya besarkan sikit. Okay.
Doktor Lek.
Doktor, let go.
Dah lag lagi.
Okay, now is it clear to you? Hello everyone.
Hello, doktor.
Hello doktor.
Hello, doktor.
I dah pindah tempat dah.
Sekarang okey.
Oh, sekarang okey. Okey, tapi cuma suara saya akan bergema and mungkin akan dengar apa ada cerita dan ketawa dekat bawah tu, okey?
Tak apa, doktor. Okey je, doktor.
Okay. Alright, so kita akan belajar about the relation between concentration and conversion. Okay, you have to know how to relate the C with the X. Okay, and then you need to use all the information and tabulate in a stoichiometric table. Okay, so there is a template of the table. Right, it's just that you... Yeah.
Ada share ke?
Doktor, macam tak share screen je.
Ya Allah Tuhanku. Sekejap Sana, what's wrong with me today? Okay, alright. Okay, I don't know
dah
what's
nampak
wrong.
sekarang.
Okay, nampak dah?
Okey, dah.
Dah doktor.
Okay, alright. Okay, so all the information you need to tabulate in the table. Okay, there is a template of the table. It's just that you need to know how to put into each of the column the information. And also at the end of this chapter, you need to learn how to to know the material balance between this kind of reactor. Okay, so each of the reactor will have a different equation. Alright, so you cannot mix it. If you mix it, you use the wrong formula, you will get the wrong value. Okay, alright, so this is the one lah yang anda explain. Okay, so for the first thing is you need to know what is the conversions. Okay, always remember the conversion is equals to mole of I reacted. or with the mole of fat. Okay, so means that X is equals to Na naught minus with the Na. This one we want to know how many moles are being reacted over with the initial one, which is the Na naught. Okay, so when we handle with the V constant, let's say if the V is constant, the volume is a constant. Okay, we can convert it into the concentration. Okay, which is X will equals to this one you can cancel it and become 1 minus Na. Alright, this one is divided by V, and also the denominator also divided with the V. Okay, so you will have, you can simplify into a X is equals to 1 minus Ca over Ca naught. Okay, so from here actually you can rearrange it, alright, in order to get the final one, which is Ca is equal to Ca naught 1 minus X. Okay, you just rearrange this one. Alright. Okay. So clear. Okay, now we move into the stoichiometric table. Okay, just now it's just to recall. Okay, recall what's the definition of the conversion. Okay, so stoichiometric table, okay, is used to present stoichiometric relationship between reacting molecules for single reactions. Okay, so this stoichiometric table only can represent a single reaction only. Okay, you cannot have a multiple steps. All right, multiple reactions. Okay, so here, what does it mean by stoichiometry? Is by looking at this small capital letter here, small letter here, okay, which is A, B, C, and D. Okay, so we recall back what you learned in topic number 1. All right, used to relate the stoichiometry with the relative rate of reactions. Okay, so we just get a negative Ra is over with the A, Rb is over B, and we have Rc and Rd. Okay, this would be in the positive sign since it is formation. Okay, formation of the molecules or compounds C and D. All right. So if A is limiting reactant, okay. Let's say if you choose A as a limiting reactant, all right. Basis of calculation is taken as per mole of A. Okay. So you have to divide all the all the compounds here, which is the B, all right, C and D with the stoichiometry of A here. Okay. All right. Sekejap okay, so dia ada iklan sikit. Then we develop the stoichiometric relationship for species in the reaction that will show us changes in mole for each species by constructing stoichiometric table. Okay, so this stoichiometry actually in order for you to know what is the initial concentration, okay, what is the changes happen inside the reactor, and what means that what's remain in the reactor, and when it leave, it becomes what equation it would be. Okay, so proceed to the next one. Okay, so in stoichiometric table we have a batch system and flow system. Okay, so in this topic we will look at the in terms of liquid or gas. Okay, batch and flow system. Okay, so usually batch lah, and flow kita akan boleh guna for Cstr and also PFR reactor. Alright, so this one pun batch boleh juga Cstr reactor, tapi the work as a batch mode operation. Okay, so let's say this one we can have a what do you call it, a constant volume, and this one we have also a constant flow rate. Okay, so this is flow, this is a batch. Okay, nanti you akan ni lah tahu how to differentiate between both. Okay. Let's say if it's a batch, all right, means that the remaining here would be the same compound leaving the reactor. Okay, so at the time, anytime it will become Na, Nb, Nc, Nd, and Ni. Okay, so if you can see for T0, we don't have like Nc naught. Okay, we don't have Nc naught. We don't have Nc naught and Nd naught. Okay, sebab the product will not being formed at T0. Okay, so species A is our basis of calculation. Okay, so you need to refer to the species A, which is the limiting reactant. Alright, and A0 is the number of mole of initially present in the reactor. And then we have a NOx. Okay, so what is NOx? It's the moles of A consumed as a result of the chemical reaction. Okay, so and A0 times with the conversion, we will have the how many we can calculate how many of moles A being consumed or reacted. Okay, so the living one, all right. Okay, we will have a N here, Na here. So Na here is equal to Na0 minus NOx. Okay, so this one after certain time ataupun dekat at any time. Okay. Oops. Okay, so Na is equals to Na0. This one is the initial, alright, the initial present here, alright. Dia akan minus with the one that being reacted here, which is the NO times with the conversion. Okay, depends on the value of the conversion. Alright, then we will be able to know what is the concentration, what is the number of the mole of A remain ataupun leave the the reactor. Okay, so this lah the buat punya ni. Okay, so you can simplify it, alright, by taking out the Na0 times with the 1 minus X. Okay, right. So we want to determine the number of moles of species B remaining at time T. Alright, after NOx moles of A have reacted, for every mole of A that reacts, B over A moles of B must be reacted. Okay, so let's say you have a stoichiometry. Initially, we have a A here. Okay, so we want to make it A as a limiting reactor. So you have to divide A for each of the compound involved here. Alright, left side and the right side. Okay, you have to divide by A. Alright, so if you want to know moles B reacted is B over A NOx. Okay, so this is the one that being consumed. Okay, just now kita ada untuk for A punya moles. Okay, yang reactors adalah NOx. Okay, so kalau you ni untuk A. So kalau you nak tahu B, of course you kena tahu fraction dia, which is B over A and A0x. Okay, so same apply with C. Kalau nak being informed, dia akan jadi C over equal C over A and OX. Okay, ni I akan terangkan nantilah, nanti you confused. Alright, so the number of moles of B remaining in the system would be, alright, so use back the principle that I explained you before, which is we have this one is the initial one, initial number of moles of B, which is NB0, minus with the B over A and A0x. Okay, so means that minus ni dia dah being degraded lah. Alright, kalau nanti kalau dia being formed, dia akan jadi positive here. Okay, so NB is equal to NB0 minus B over NOx. Okay, so this is the initial moles of B minus with the moles of A reacted. Okay, then you will be able to get what is the NB. Okay, berapa NB yang terkeluar ni lah. Alright, okay. So to determine the number of mole, alright, of each species remaining after NOx mole of A have reacted, we form the stoichiometry table. Okay, so because of what we need to use the stoichiometry table, if you can see at the right bottom here, alright, for the remaining one. Okay, so it will relate to the Na0 here. Alright, so kita nak tallykan dia jadi satu. Okay, so that when you do the calculation, you can use this single value in order to obtain NB, NC, ND and so on. Okay, so for column 1 here, okay, we have a species. Okay, depending of the how you categorize ataupun you denote the compound for the reactant and for the what you call it for the product. Okay, so let's say A and B is the reactant and C and D is the product. Okay, so this is reactant and C and D is the product. Okay, then we have another one which is inert. Okay, inert ni adalah special case. Okay, then we have a column number 2. Okay, with this one, which represent the initial concentration ataupun initial value lah. Alright, initial mole. Alright, so we have Na naught, Nb naught, Nc naught, Nd naught. Okay, even though this is 0, you just put it first. Dia punya ni lah, dia punya ni. Okay, and we have a change. Alright, remember for this one is minus Na NOx X, which is Na is equals to Na naught minus with the Na naught X. Okay, ataupun we have a Na naught, kalau senang ingat is 1 minus X lah. Alright, then we have a Nb, alright, which is equals to Mb naught minus with the Ba Na naught X. Okay, remember yang ni adalah moles of A reacted. Kita akan refer semua sama je kat sini. Moles of A reacted. Okay, yang differentnya adalah kat sini. Okay, so for Nc actually we have a Nc naught, alright, plus, okay, remember formation should be plus or equal plus Ca times with the Na NOx X. Okay, same as Nd, which is Nd is equal let me write here. Nd is equal D over A Na naught X. Okay, so the remaining would be this one. Okay, masukkan balik saja berkaitan dengan ni. Okay, so make sure your number 2 and number 3 column must have the correct equation. Okay, if not you get the wrong equation at the right side here. Okay, so for Ni naught, because dia macam inert, so dia tak react dengan apa-apa kat A tu. This just macam present dia ada dalam ni, present in this reaction, tapi dia tak ada reaction. Okay, that's why with Na naught here. Okay, they stand alone. Alright, so this initial mole for each of the compound you can denote it as Nt naught. Alright, so Nt naught is equal Ni naught plus Nd naught, Nc naught, Nb naught, Na naught. Okay, so the whole one which is N total is equal to N total naught. Okay, N total yang ni lah tadi yang cakap tadi, yang second column, plus with this one you can take it out. Okay, for the Na naught X here you can take it out, and then plus with D over A plus C over A minus over B over A minus 1. Okay, so this will be the overall of the remaining molecules atau compound. Okay, so far are you clear with my explanation? Are you able to catch up? Okay, alright, thank you. Okay, now we proceed to next one. Okay, okay. So now we have let's say we have a reaction involve this equation. Okay, so remember just now the N, the total numbers remain in the reactor. Is about Nt naught plus D over A plus C over A minus B over A minus 1. Okay, so this is the overall one. Okay, ini 1 sebab A over A. Okay, that's why it becomes 1. Alright, times with NOx. Okay, so actually this one can be simplified with del. I don't know the name of this symbol, tapi panggil dia del. Okay, so this del represent with this equation. Okay, the one that you divide the Stockholm equation with the Stockholm equation of A. Okay, so this is the one lah. You can simplify it into this equation. Alright, del. Okay, so the del actually the definition is change in the total number of moles over moles of A reacted. Okay, okay. So why not if we do some exercise here? Okay, what would be the answer here? All right, for del. Okay, so we have a 2A Alright, we have a B and then we have a 3C. Okay, anyone wants to try? Okay, boleh jot down dulu kertas sendiri. Okay, saya lupa nak cakap suruh prepare kertas semua tu lah sebab kita akan buat exercise jugalah dalam ni sikit-sikit supaya you faham lah. Alright, okay, so daripada sini kita kena jadikan this ammonia gas into what they call it, into a limiting reactant. So it will become A is equals to B, alright, over 2 plus with the 3 over 2C. Okay, so the del would be, alright, okay, remember dia kena start dengan what they call it, product. So it become 3 over 2. Okay, ini sebab saya dah divide kan siap-siap. Okay, so what they call it, and then plus with the 1 over 2. Alright, and then minus with 1. Okay, so it will be the answer lah. Alright, okay. Alright, so from this number of moles, okay, usually we won't give the value in terms of the number of moles, okay, sebab dia terlalu banyak lah, nombor tu akan jadi 10 to the power something, okay. So we need to what do you call it, to convert into the concentration, okay. So this one is applied to the volume batch concentration, which V is equals to V naught. Okay, means that there is no what do you call it, there is no changes in the constant throughout the reaction. Okay, so this is applicable to this. V is equal to V naught. Okay, so remember from the previous one, we have this one, yang atas dia, okay, and also this one, okay, and so on. Okay, so how to convert into concentration? Remember, concentration is equals to number of moles over with the volume. Then you will get the concentration. Okay. So all of it, okay, and this one is you can divide jugalah untuk jadikan dia ni lah what they call it, concentration. Okay, nanti I akan ajar macam mana kita nak ubah NB naught ni. Alright, so this is how you get lah. So NB over V dengan NC over C, ND over V. Alright, okay. Lepas ni I akan ajar macam mana nak tukar NB and ND naught into satu simbol sahaja. Alright, theta. Alright, so we further simplify this equation by defining the parameter theta I, which allow us to factor NA naught in each of the expression for concentration. Okay, sebab kita nak masukkan NA naught ni untuk setiap equation. You don't want to have a NB naught, NC naught and ND naught here. Alright, so for the CA, there's no problem with it. Alright, sebab NA naught ni dia stand alone je lah. Alright, then we have NB naught here. Okay, so from here, if you want to convert, alright, you need to have this one first. Okay, so theta I, alright, is equals to what do you call it, NI naught over NA naught. Okay, let's say you want to what do you call it, to convert the concentration of B. So this one it should be NB naught over with the NA naught. Okay, so I is a species of any compound. Okay, can be B, C, O, D, O, E, F, and so on. Okay. So from here, alright, if you can see, to convert into theta, we need to divide by NA naught. Okay, so NA naught here, alright, we can put it, we can divide it, NA naught here. Okay, so that's why we have, okay, yang ni lah which is NB naught over with the NA naught, alright, minus with the B over A, okay, and then we have a NA naught, alright, okay, divided by NA naught, is sebab kita nak matikan N naught kan, alright, times with the X, and then over V, okay, so here we can replace it with the theta B, okay, and then minus B over A, tinggal X saja, so that's why we have this one, okay, same as this one, alright, so theta C would be the NC naught over with the NA naught, okay, so all of these need to be divided with the NA naught. Okay, so you cancel ni, this one become theta C. and so on. Okay, so make sure this one should be positive lah sebab it is on the right side, which is the product formation. Okay, anyone clear with it? Okay, anyone? So okay tak semua orang? Everyone, are you clear? Okay.
Doktor, saya tak
Ya.
dapat.
Ya, yang tak dapat yang mana?
Yang macam mana boleh jadi cubic yang potong-potong tu, kat potong-potong tu.
Oh, potong ni ke?
Ah.
This one ke? Okay, sebab macam ni. Mula-mula kita
Ya.
tengok definition of theta ni kan. Okay, let's say kita concentrate pada theta B dulu, okay. So, dia akan jadi theta B, okay, is equal to, okay, sebab ini kita nak replace with B, right? So, it become N B naught over with the N A naught, okay. Alright, so kalau you tengok initially equation ni, okay, macam mana you nak jadikan dia theta? Okay, kalau you tengok ni dia kena over with NA naught, betul tak? Okay, so this one, alright, the initial one yang you buat daripada Stockholm Table tu, okay, remember this is the remaining one, okay, which is dia ada N B naught over with, minus with the B over A, alright, N A naught times with the X, okay, kita ada over V kan, so nak jadikan dia theta, you kena over dengan NA naught. Okay, so automatically sini kena over NA naught. Okay, this one over NA naught. Okay, you tak boleh kacau V ni sebab dia per. Okay, dia dekat arah yang lain. Okay, so daripada sini you automatically jadikan dia theta B. Okay, B over A, this one jadi B over X je lah. B over A times X. Okay, clear tak? Yang kepada yang bertanya tadi sebab saya tak nampak nama yang
Ni macam mana NB naught tu boleh potong jadi QB? Memang macam tu je?
mana QB? Oh, Pak, QB ni.
NB naught tu macam mana dia boleh potong je jadi QB?
Ni ke maksud you?
Mana kerja doktor, saya tak nampak.
Okey, sekarang ni okey, kerja saya sini. Okey, nak tengok yang mana? Ni. Ni.
Saya nak tanya yang NB naught tu kan NB naught over NA naught. Yang sebelah tu.
Yang sebelah dia ni.
Yang question tu. Macam mana boleh jadi NB naught tu boleh jadi QB?
Oh, sebab saya dah perkan ni dengan NA naught. Saya dah perkan yang ni dengan NA naught, yang ni pun saya perkan NA naught. Okey, sebab nak jadikan QB, Q saya main theta. Theta B ni dia kena equation dia kena macam ni.
Oh, okey, maksudnya nak jadi. Oh, faham.
Okey,
jadi
faham
QB
ke?
tu kena NB naught over NA naught. Baru akan jadi QB.
Ya. Sama dengan theta C lah, theta C dengan theta D, which is the ND naught over with the NA naught. Yelah. Okay. So ni automatic akan jadi boleh replace dengan theta. Tapi you kena bahagikan NA naught lah. So that's why kalau you perasan sini, dia dah tak ada NA naught dah. Sini pun tak ada. Okay, sebab you dah cancel, you dah perkan dah atas ni dengan NA naught. Okay, faham?
Faham, doktor.
Okay, Alhamdulillah. Okay, saya proceed je. Okay, so kita proceed ke next one. Okay, yang pasti ni je lah yang you nak ingat paling senang lah macam nak convert theta, you kena bahagikan semua dengan NA naught untuk B, C, D, N, E, and F semua tu lah. Alright, compound. Okay, so this is the compound. Okay, so ini yang tadi, alright, kita dah pecahkan dia jadi theta. Okay, ni kita dah pecah jadi theta, ni kita dah jadi pecah jadi theta, jadi macam ni. Okay, so kalau you tengok sebelum ni, ni lah ni yang kita buat. Okay, so kenapa kita nak bawa keluar dia punya theta? Sebab kita nak jadikan dia concentration senang. Bila awak keluarkan satu ni, cuba awak tengok NA naught over V here. Okay, dia akan jadi CA naught. Okay, so dia tak payah kacau kat dalam ni. So ini, you akan jadi CA naught. Okay, so this one akan jadi CA naught. Okay, faham? Alright. So daripada situ, you akan simplifykan jadi macam ni lah. That's why you boleh convert yang cerita tadi daripada number of moles, convert to concentration. Sebab remember concentration is equal to number of moles over with the V. Okay, with the volume. Alright, so this one you can simplify become CA naught. Alright, so the rest would be remain here. And then we have same also which is the CA naught theta. Alright, remember you dah jadikan ni theta, ni kita pangkah jadi theta. theta C. Alright, yang ni dia dah pangkas x and n naught over n naught. Okay, that's why dia remain x. So dapat yang ni lah. And then seterusnya. Okay, so this is how you get lah. Alright, so let's say we have a CA to CB. Okay, reaction of A plus B equals to C plus D. Okay, this is A, B, C, D. Okay, cuba try sekarang. I give you 3 minutes. Okay, ikut dia dalam atas ni, macam mana at the end you akan dapat this one. Okay, remember kalau kita nak tahu C which is negative RA is equal to the red law is CA, CB. Okay, macam mana you dapat benda ni? Okay, boleh try sekejap. I bagi you 2 minutes. You can just masukkan what is CA and what is CB. Okay, do you have, can you get this same answer? Okay, tak apa, cuba sekejap. Okay, boleh ke? So you just masukkan which is this one. Okay, so we have a K here. Alright, what is CA? CA is this one. CA naught 1 minus X, and we have a CB. What is CB? Alright, CB is the CA naught theta B, alright, over B over X times X. Okay, so this one is, okay, that's why you have K CA kuasa 2, you multiplykan yang ni. Alright, and then we have 1 over 1 minus X and theta B minus BA X. Okay, so ini equation dia. Okay, memang mula-mula ni memang susah sikit you nak catch up. Okay, sebab dia banyak sangat macam arrange lah apalah. Okay, tapi tak apa. You try to, what do you call it, try to absorb lah apa sebanyak mungkin during lecture, and then you try to go through again the lecture notes. Alright, nanti you akan jadi pro lah insyaAllah. Okay. Alright, so far okay. Sebelum I move to the next slide.
So far okay.
Okay, Alhamdulillah. Alright. Okay, so kita try buat satu exercise. Okay, this one is about liquid phase reaction. Okay, this one you can find the formula actually. Alright, so I malah nak baca soalan ni, macam panjang kan, sebab kita banyak lagi ni. Okay, so we have a sodium hydroxide here. Alright, and then react with the what you call glycerol stearate. Alright, and then it will form the sodium stearate and glycerin. Okay, this is glycerin. Okay, so this one we just put it as 3A. Alright, and then plus with the B, and then we have a 3C plus with D. Okay, so you need to set up a stoichiometric table. Alright, representing, expressing the concentration of each species. Alright, in terms of the initial concentration and also the conversion of X. Okay, so what you need to do is, okay, I tunjuk dulu sebab ni nanti kita baru buat latihan. Okay, so remember you have to over with this A, some of the equation for each of the compound. Okay, so we have a 1 over 3. Okay, initially sini ada 3 kan, so kita bawa ke bawah semua. Alright, okay, so it becomes 1 over become this one. Okay, sebab initially kita ada 3A plus with the B, alright, equals to 3C plus with D. Okay, that's why you will have this equation. Okay, when you divide these 3 with all the components of B, C and D, each of the components. Okay, so from here we assume that it is in a liquid phase reaction whereby it has a V constant, the volume is constant. Okay, so that you can convert the number of moles into concentration. Okay, so basically CA is equal to NAV kan? Ingat, remember, this is the basic equation. untuk of consideration. And we have a NA over V naught. Okay, sebab kita kenapa kena letak naught ni, sebab kita nak tallykan dengan initial. Okay, sebab dia akan remain sama je, V is equal to V naught. Okay, that's why we want to make it as a initial 1. Okay, sebab kita nak tallykan dengan NA naught. Okay, the initial. Okay, so here we have a, what is NA? Remember, NA is equal to NA naught 1 minus X. Okay, so kalau you tak ingat ni, you go back to the basic one, which is, what is X? Okay, moles of reactant, alright, over with the initial mole, alright. So you boleh rearrange ni lah, you akan ingat balik. Okay, so daripada sini kita akan convert lah, this will be become Ca0, alright. So kita nak simplifykan dia, you just remember theta I is equal to theta I, alright, naught over with the theta kat C over with the ataupun N ke, dia boleh je mana-mana sebab benda ni adalah unitless, alright. And then we have a Ca0, okay. You also can have ini in terms of lain lah, N pun boleh, alright. Ataupun this one you can have Ni0 over with the Na0, okay. So I akan jadi B ke C ke and D. Okay, so you need to do the table. Okay, we have a species one. Alright, you just put it the molecular formula for each of the species, and there is a symbol here A, B, C, D. Okay, and it's assumed that there is a water as an inert. Alright, there is no reaction with the water. Water ni sebagai macam gas nitrogen tu lah, dia just inert. Okay, so we just put it a symbol as A, B, C, D, I, and then the initially would be Na0, NB0, NC0, and D0. Alright, and this we have Ni0. Okay, Ni0 saja. Ni nanti dulu tahu ni yang total. Ni bawah ni dia sebab dia terlalu pack sangat. Ni should be total ni. Okay, so we have a change here. Okay. Nanti I akan letak ni lah total, nanti lah ni kat bawah sebenarnya ni kita assume yang dulu. Alright, so change dia adalah Na0X. Okay, remember change adalah mole yang reacted of A. So and then this one kita ambil je balik sini 1/3, tapi remember since this is dekat left side, dekat reactant should be minus. Alright, and Na0X. And then we have a C here. C kita tak ada kan, kita ada satu saja kan. Okay, so Na0X. Okay, this one plus. Okay, and then we have a for D, which is plus with 1/3 Na0X. Okay, and remember for the inert tak akan ada reaction here, so should be 0 here. Okay, dia ada initial sahaja. Okay, alright, so kita tengok pada remaining. So remaining ni adalah berkaitan dengan initial and change, dua kolom ni. Okay, so you just put it, alright. Remaining should be Na0 minus with the Na0X. Okay, tapi dia rearrangekan become like this. Okay, and Na0 ni dia bawa keluar. Alright, and then here remember okay, from NB0, okay, minus with the 1/3 Na0X. Okay, in order for you to convert into theta, alright, you have to divide it by Na0. Okay, sebab kita nak adjustkan ni, dia jadi NB0 over with the A0. Okay, so here over with the Na0, okay, you masuk angka, so sini akan jadi theta B. Alright, so it become this one lah. Nah, yang you ubah ni lah. Okay, alright. Okay, so this one theta C plus X and theta D plus X3. Alright. Okay, and then this one you just convert lah daripada ni. Ni daripada slide yang sini je. Okay, keluarkan Na0 dekat sini. Kita akan dapat V0. Okay, so this one you keluar ni lah. So yang untuk C pun sama, which is NC0, alright, which is Na0, alright. Plus with the Na0X. Okay, sepatutnya dia kena Na0X ni sama ada you boleh buat letak sini atau you boleh letak atas kat luar sini pun boleh. Okay, so dalam sini dia letak kat luar. Okay, Sebab sebenarnya dia letak kat luar sebab dia nak memudahkan kamu. NA0 over V is equals to CA0. Okay, so at the end dia akan jadi benda alah ni. Alright. Okay, so far faham ke?
Boleh sikit-sikit doktor.
Okay, faham tak? Yang penting kalau you tak nak perkan ni, you boleh letak NA0. Okay, I nak bagi clear lagi sekali lah. Okay, contohnya NA0 over N. Okay. Alright, so sini ini boleh jadi theta B. Alright, NA0 ni dia sepatutnya dengan N kan? NA0 juga kan? Tapi you boleh letak dekat luar lah, which is NA0 over theta B 1 over 3x. Okay, so NA0 ni kat luar lah. Ni just perkan ni. Okay, so this would be the NT dengan ni lah CI0. Okay, so ini dia akan automatic CI0 sajalah untuk inert. And this one is NI0 sama dia NT sama dengan NT0. NI0 ni lah. Okay, so this one lah. Okay. Okay. Alright, so okay, kita buat sama-sama untuk ni. Alright, ya Allah, dia punya pecah sikit lah dia punya gambar. Kita akan bagi information dia. Alright, dia kata untuk cari what is the concentration of glycerin when the conversion of sodium hydroxide is 20% and 90%. Okay, so glycerin tadi adalah D. Alright, the product. Okay, so sodium dia, we have a 10 initial concentration of sodium hydroxide which is NaOH. So dia dah bagi dah Ca0 adalah 10 mol per decimeter padu ni. Okay, and then we have a glycerol stearate which is the stearate which is this one is Cb0 lah, 2 mol over decimeter cube. Okay, so this is the X. So you can cari what is a CD bila conversion dia dekat X equals to 20%, another one which is X equals to 90%. Okay, so you can ada dua calculation yang berbeza. Okay, so you kena cari, okay, let's say for A, kita nak cari what is a CD at X equals to 20%. So macam mana nak dapat CD? You tengok balik dekat sini. Okay, alright, so this is the equation. Alright, which is CD is equals to, okay, you tengok kat situ, which is Ca0, okay, theta D, alright, plus with the, this one, X over 3. Okay, so theta D, kena keluarkan balik lah, what is theta D is equals to ND0 over NA0. Okay, so ini adalah kosong lah. Ataupun you akan tulis CA0 pun boleh, CD0 over dengan CA0. Okay, so this one kena kosong sebab tak ada T at 0, CD akan jadi kosong. Okay, so sini kosong. So you just plug in the value of CA0 which is 10, alright, plus with the X which is 0.2, okay, over X. Okay, you have the CD. Okay, and B pun you refer to the same equation. Alright, it's just that you need to change the value of the X into 0.9.
Sorry doktor.
Ya, suara dia kenapa?
Boleh ulang balik tak yang pasal theta D yang T at 0 tu?
Oh,
Saya
theta
tak
D.
tangkap.
Okay. Alright. Okay, theta D. Okay, kan theta D kan bersamaan dengan N atau ND0 over NA0 ataupun kita boleh buat dalam concentration kan? CD0 over with the CA0. Nampak ke saya tulis?
Nampak doktor.
Okay, so remember product dekat time 0 tak ada. Okay, there's no NC0, we don't have ND0, we don't have CC0. Okay, that's why kita boleh pangkahkan dia 0. Alright, so you just concentrate yang dalam ni je lah. Okay, faham ke?
Faham doktor.
Okay, alright. Sakit tekak lah pula ni. Alright, okay. Nanti kita akan recap dulu lah juga sebelum habis nanti. Okay, okay, so you nak break 2 minit ke atau nak teruskan?
Break madam.
Okay, break lah dulu. Okay, break 2 minit, okay? Lepas tu make sure join balik tau. Okay, break lah dulu.
Ya, okay, sure.
Okay.
Madam, Dia ada busy ke? Saya nak tanya soalan ni.
Yes, on the meantime boleh je siapa nak tanya soalan dia. Nak tanya apa?
Saya nak tanya soalan yang dekat slide example 3 to 4.
Sekejap saya undur balik.
Example. Yang ni.
3-2 Oh, dia
Ini.
for addition. Okey. Lepas tu,
Soalan dekat concentration tu, table bawah kanan tu, bawah sekali kanan. Kenapa dia punya equation dia tak sama dengan equation yang kita try sebelum tu, yang sebelum slide sebelum lagi?
Yang mana? Yang macam ni ke sama?
Sama
Cuma sebenarnya bila awak tengok, sebab kita start dengan number of moles tau. Okey, kita macam ni, kita start dengan, mari saya tulis. Kita start dengan number of moles dalam bentuk N. Okey, alright, lepas tu kita try tukar, nak tukar daripada yang ada NB0, alright, yang ada NC0, yang ada ND0 into theta. Okey, sebab kita nak letak dia dalam bentuk NA0 saja. Okey, sebab kita nak ultimate aim adalah NA0 saja. Okey, so kalau you nak kira misalnya, orang tak akan bagi number of moles untuk kita kira, dia akan bagi dalam concentration. Okey, that's why kita nak jadikan dia, nak tukar senang, contohnya kita nak refer satu type saja. Okey, katakan kita nak concentrate CA0. So CA0 adalah equals NA0 over V kan? Okey, so the one that kita construct sebelum ni, yang ni lah saya bagi. Dia panjang sebenarnya. Ni, daripada ni. Alright. Yang mula kita belajar tadi batch, kita nak jadikan dia dalam bentuk concentration. Okey, that's why kita nak per dengan V. Nak dapat concentration. Okey, tapi sekarang ni V kita adalah kena samakan dengan V0 sebab dia adalah constant volume. So dia tak berubah. So disebab awak put dia V0 lah. Sebab sini dia, sebab kita sekarang tengok pada initial. Kalau you tengok ada not. So you kena adjustkan lah dia not. Okey. So daripada sini you agak sukar untuk kalau contohnya dekat sini lah kan. Yang ni tak ada masalah untuk A. Yang ni. Bila you nak perkan, nak jadikan concentration susah. NB0 over V0. Okey. Sebab kadang orang tak bagi value of CB0. Dia just bagi value of A sahaja. That's why kita nak tukar semua jadi in terms of A. Alright. So macam ni kita nak relate kan. Okey, kita tengok NB kan. So NB, sekarang ni NB is equal to NB0 minus with the B over A and A0 X. Kita tukarkan dulu theta baru kita fikir pasal C tu nanti saya cerita. So daripada sini nak tukarkan dia, ingat theta adalah NA0, betul. Boleh cakap sekali? NA0. Betul. So kita akan jadikan dia NB0 over NA0. Yang ni BA over NA0X. So dekat sini, ni automatik akan jadi theta B kan? Sebab kita nak tukarkan, ingat kita nak tukar NA0 dengan V0 kan? So NA0 ni bawa keluar. So dia akan jadi, saya buatkan sini NA0. Alright, darab dengan ni dah tukar kan? So jadi theta B. Minus with the BA here. X. Sebab NA0 you dah bawa keluar. So kalau you nak jadikan concentration, sini tak jelas CA0. So this one would be the V0. So this one you akan jadi CA0. So dia akan jadi CA0 times with the theta B over B over A times X. Ni lah yang you nampak ni. Sekejap. Ni. Faham?
Faham doktor.
Faham ya? Dia macam dia ubah dekat sini lah. Yang ni lah cerita tu lah. Kita ubah-ubah lah. Atas kita nak jadikan dia CA0. Alright. Yang lain nak sambung ke? Itulah saya rasa agak challenging sebenarnya bila kita online class. Cakap saya rumah saya ni sebab kat bawah tu anak saya tengah PDPR dengan online class juga. So dia agak macam ni lah. Alright, semua are you ready for the next slide?
Yes, ready doktor.
Good.
Yes doktor.
Bagus. Sebelum ni kita tengok batch vector with constant volume. Okay, sekarang ni tengok variable volume. Okay, nanti akan jelaskan dari kategori lepas ni. Okay, so daripada sini remember yang you belajar tak ingat thermodynamic lah kot. Alright, individual concentration can be determined by expressing the volume V for batch system or volumetric flow rate or V for a flow system. Okay, so kita ada V besar ni adalah untuk volume. Okay, and then V yang macam ni kita panggil dia as a volumetric flow rate. Okay, this is flow system. Okay, ni batch ni flow. Okay, dia ada dua kategori. Yang terangkan adalah batch dengan flow. Okay, as a function of conversion using the following equation of state. Okay, so ini adalah mostly untuk gas. Okay, variable volume ni kita concentrate pada gas. Okay, so we have a PV is equal to Z and T times with RT. Okay, so we have a K, ATM. Okay, tapi dia akan berubah juga value ni depends pada R dia. Okay, kadang R dia dalam mol per K apalah whatever lah kan. Okay, ikutlah pada dia punya sini gas constant dia apa. Okay. Okay, so from here we have this equation is valid at any point in the system at any time. Okay, macam sama juga kita ada proses whereby we have a T naught here and we have a any T here. Proses yang berlaku at any time. Okay, so what we can do, we can equate it into one. Okay, kita macam nisbahkan lah, which is PV is equal to Z and T. See, this one is at any T and this one is T is equal to 0. Alright, TRT over with the, okay, this one is P naught sebab dia dekat time 0. Alright, over with the Z naught and T naught R T naught. Okay, so daripada sini kita boleh equatekan dia, kita equate dia kan, then kita akan dapat this kind equation. Kita rearrangekan in term of V. Okay, rearrangekan in term of V ni. So kita tinggalkan dia seorang-seorang, bawa lah semua ni ke arah sini. Okay, that's why you will have this one, this equation at the end. Okay, so you need to remember, alright, in variable volume, I rasa dekat topik number 2 yang last tu, dia cakap, ingat tak ada this symbol, alright, which is kalau flow, we have a variable volume 1 plus epsilon x. Okay, tak tahu you panggil apa, tapi panggil epsilon. Alright, so here, okay, how we define this 1 plus ex actually is from this one. Okay, so NT over NT naught is equals to 1 plus EX. Okay, so this one 1 plus EX. Okay, nanti I akan terangkanlah after this lagi details apa benda ni. Okay, and usually this one kita assume dia ada system, Z ni akan equal to Z naught. Okay, so this one kita boleh omit dia. Alright, okay. Itu just introduction. Okay, so this is volume on volume flow rate. Okay, I pecahkan dia supaya you nampak clear lah. Actually, this one available in the formula juga, buku teks. Okay, we have a liquid phase and gas phase here. Okay. So, liquid kita assume it is incompressible. That's why dia tak ada Z. Okay. So, we have a batch system plus with the flow end flow system, whereby the batch system is concentrated on the volume. Alright. And this one is volumetric flow rate. Alright, volumetric flow rate means that selalunya dalam bentuk decimeter cube over second lah. Alright. Okay, so this is for constant volume lah, dengan constant volume saja. Alright. So kalau you and flow adalah untuk CSTR dan PFR ni I cakap tadi lah daripada awal tadi. Alright. Okay, so we have another one which is in term of gas. Gas ada dua, sama ada dalam bentuk constant ataupun variable here. Okay, so bila constant volume, dia akan jadi V O equals to V naught and V is equal to V naught. Okay, so nanti kita akan belajar lah ni. Alright, and then we have a variable volume whereby, inilah yang I ceritakan tu. Okay, nanti kita akan learn lah after this. Okay, so this how you get this adalah daripada previous slide. Okay, so that's why kalau boleh you try buat mind map. Dulu I belajar CRE ni, I belajar sendiri sebenarnya sebab I background bioprocess sebenarnya. Okay, so you kena buat mind map and masukkan mana satu equation dalam setiap kategori ni so that you have a clear view lah, you tak mix. Alright? Okay, so we move on to nt equal to nt naught plus delta nn naught x. Okay, so this one actually is the one that you learn juga sebelum ni sebenarnya, yang macam Stockholm Table. Alright? Okay, tak apa, kita go one by one. Memang I faham you macam a bit macam confused sikit. Okay, sebab banyak sangat ni kan equation. Okay, kita buat slow-slow. Alright, so basically we have a NT, alright, and total of moles equal to the initial total of moles involved. Okay, they become ada A naught and B naught and C naught and D naught. Okay, plus with the delta and A naught X. Alright, remember what is del here? Alright, so del here is about that yang you dapatnya D over A plus with the C over A minus B over A minus 1. Okay, so this one we can divide it into of nt naught. Okay, so this equation 3-33 kita boleh divide dia dengan nt naught. Okay, remember yang kita buat tadi yang ada PV and R whatever tu. Okay, kan kita nak daripada relatifkan dia dengan T naught dengan T at any time kan, sama jugalah. So here at T at any time kita divide by NT naught. Okay, so kita divide lah ni. Sini kita divide NT naught, this one kita divide NT naught. Okay, so this one we will have satu lah. Alright, here and then we have a NT over NT naught delta X. Okay, sebab apa kita nak jadikan dia macam ni? Sebab kita nak dapatkan dia dalam fraction. Okay, usually kalau gas kita jarang ada concentration yang dia bagilah, dia akan bagi in term of fraction. So contohnya oksigen dia bagi dalam 70%. Okay, so 70% ni sebenarnya kita boleh calculate the concentration. Okay, sebab setiap kali fraction dia berbeza, concentration akan berbeza. Alright. So that's why
Doktor. Doktor.
Sorry doktor lag doktor.
Doktor. Doktor.
Y. Saya tak dengar awak punya suara lah.
Sorry doktor.
Doktor. Lag doktor.
Oh, saya punya lagging eh?
Dari
Ya
awal
Allah.
tadi.
Sekejap, tadi pas slide ni saya daripada slide yang mana saya terangkan yang lagging?
Dekat potong-potong tu.
Dari yang
Lepas
ke
tu
atas tu.
lost.
dekat oh, still slide 23 kan?
Ya, still lag.
Masih lag doktor.
Doktor lag doktor, still lag doktor.
Yang slide 23 masih share. Itulah memang itu saya sebut. Hello? Boleh dengar?
Hello.
Hello, dengar tak?
Boleh.
Oh,
Boleh
okay.
doktor.
Boleh dengar. Hello.
Alright, okay. Okay, alright, kita sambung. Okay, sebab saya rasa memang internet problem and then saya share screen, okay. That's why lah kot. Sekejap okay, saya masih... Okay, so boleh saya continue kat nombor 23 atau nombor 21? 23 okay? Slide.
Okay, sir.
Dekat equation 333.
Tiga. Okay.
3-33.
Alright, saya sambung balik. Okay. Alright, okay. So daripada situ, okay, kita tengok dulu pada total number of moles. Okay, we have a NT is equals to NT naught. Okay, ini macam lebih kurang macam yang Stockholm Table. Alright, is equal to del NA naught X. Okay, sebab del ni kita dah summarize sebenarnya daripada sini. Okay. So sekarang ni kita tak boleh nak tengok pada total. Okay, so what we can do is kita kena ada basis dia, which is kita refer to the initial of A. Alright, so you need to divide, alright, all this with the NT naught. This one also NT naught and this also NT naught. Okay, sebab apa? Kita nak tengok in term of fractions. Okay, which I told you before, NA naught over NT naught is equal to YA naught. Okay, sebab at different fraction of gas, okay, selalu kalau you akan tengok composition of gas in term of percentage kan. Okay, so setiap kali percentage berbeza, concentration of the gas akan berbeza. Okay, that's why kita nak jadikan dia fraction. Alright, so from here, okay, you divide by T naught, alright. Okay, this one becoming 1 and then we have NA naught over NT naught. Okay, so this one you can simplify into YA naught del X. Okay, this is the one lah. Okay, so bear in your mind NA naught over NT naught is a fraction. Alright, so you can replace it with YA naught here. Alright, and kita boleh reducekan lagi these terms, alright, which is you kena ingat, which is epsilon is equals to del YA naught. Alright, that's why you akan dapat at the end this one. Okay, alright. So tengoklah dia simplify macam mana. Okay, so where YA naught is more fraction of A initially present, if all the species in the generalized fraction are in the gas phase, then it becomes, ni ingatlah, remember macam daripada tadi yang awal. Alright, which is change in the total number of mole over mole of A erected. Okay, alright semua? Clear?
Clear, Doktor.
Okay, alright. Alright, E naught. Okay, we dapat 1 plus EX here. Alright. Okay, kalau you tengok proses sebelum ni, kau boleh kita tak nak ada number of moles sebab yelah kita jarang bagi value of number of moles lah. Alright. Okay. So in gas system that we shall be studying, the temperature and pressure are such that the compressibility factor will not change significantly during the course of the reaction. Hence, Z naught over is equal to Z lah approximately. So kita boleh cancelkan. Alright, tadi Z over Z naught kan, kita boleh cancelkan jadi satu lah, dia sama lebih kurang. Alright, so for a batch system, the volume of the gas at any time T is, okay, this one. Alright, so we will have this equation. Okay. Alright. So ini adalah kita assume that this is isothermal. Okay, kalau kita assume this is isothermal, dia tak ada change in temperature, kita boleh cancel this one. Alright. And let's say the reaction is in isobaric. Alright. So isobaric ni adalah constant P. So this one pun boleh cancel. Alright, so the remaining would be V is equal to V naught 1 plus epsilon X. Okay, alright. Okay, so means that kalau ada sini, dia adalah variable volume. Okay, sebab dalam gas, kita gas kan, so dalam dia bukan liquid, jadinya dia boleh senang berubah volume dalam sini. Okay, walaupun dia dalam batch system. Alright, so equation 3-38 applies only to a variable volume batch reactor. Okay, dia batch reactor tapi volume dia berubah sebab dia adalah gas. Okay, gas kan boleh berubah volume sebab dia kan, yelah dia boleh randomly move. Okay, So if the reactor is a rigid steel container of constant volume, then of course V is equal to V naught. Okay, kalau container of the volume tau, okay, bukan volume of dalam tu, volume of the container tu, V is equal to V naught can be used to calculate the pressure inside the reactor as a function of temperature and conversion. Okay, ni nantilah, nanti jangan confuse dulu, kita reserve dulu yang tu dulu. Okay, so let's say we have a question number 2 here. Okay, so a gas reaction take place in a 1.5 decimeter cube batch reactor. Alright, so they have given you the volume at 75 degrees Celsius T, alright, and pressure of 2 atm, alright, which is P. Okay, and then it's given 3A is equal to B plus 2C, means that A is equals to B over 3 plus 2 over 3C. Okay, so construct a stoichiometric table on the system express the concentration of A and B as a function of conversion of X for a constant pressure isothermal batch reactor. And semua ni, okay, yang ni saya akan reserve dulu. Okay, kita akan go further dulu baru kita go back here. Okay, sebab nanti you tak boleh nak jawab soalan ni. Sebenarnya dia nak, sebenarnya exercise ni dia nak cakap yang statement bawah ni sebenarnya. Macam mana temperature and pressure boleh kira V tu. Okay, tapi tu nanti dulu. Alright, tapi kita proceed ni dulu. Okay, so we have a system here. Okay, ni macam contoh plug PFR lah. Okay, kan PFR kan dia cylindrical panjang macam ni. Okay, let's say, okay, this one we can apply also flow system for Cstr. Alright, and then PFR and also PBR. Tapi PBR kita tak cover kat sini. Ni reaction number 2. Okay, sebab dia involve solid. Alright, so we have a entering here. Alright, at T equals to 0. Okay, sebelum ni kita ada batch system je kita belajar, which is dalam bentuk N, number of moles. Sekarang ni adalah flow system, which is F. Okay, jangan confuse. Kita ingatkan dia ada flow, kita ada batch. Alright. Okay, so here, let's say we have a A, B as a reactant and then C and D as a product. Okay, so this one is at T0 whereby it enters. Okay, this one automatically akan jadi 0 lah sebab dia tak ada initially. Alright, so this is feed ataupun inlet. And then we have this one leaving ataupun kita panggil dia effluent lah, tempat dia keluar ataupun outlet. Alright, so after berlakunya reaction sini dia akan jadi FA, FB, FC, FD, FI. Okay, lebih kurang macam tadi juga NA0, NB0, and then dia keluarkan jadi NA, NB and so on. Okay, so remember what is F? F is defined of N of over T. Alright, dia akan ada unit of mole over with the second. Mole of time lah. Itu boleh kan jadi hour, minute ke, tapi basically dia adalah number of mole over time. Okay. How do you relate? Sekarang ni kita apa-apa pun kita nak relate dia dengan concentration. Okay, so how we relate it is CA. This one you kena ingat sampai you tua. Okay, what is CA? Alright, sebab you akan guna benda ni sahaja sebagai ni lah engineer. Okay, CA is equal to flow system over with the volumetric. Ingat kan, V macam ni adalah volumetric flow rate. Okay, which is FA is equal to moles over time, volumetric adalah liters over time. Okay, ni dia tak adalah liters, kadang boleh jadi decimeter cube, jadi macam-macam lah unit asalkan dia volume. Okay, so that's why dia boleh cancelkan, dia akan jadi moles over liter. Okay, sebelum ni kita tengok CA is equal to NA over V kan, sekarang dah berbeza. Okay, there should be F, alright, over V. V ni tau, V yang ni, yang cute ni ada ni, sebelah kanannya ni. Okay, alright. So same again, kan nak cakap theta ni, oh dia tak muncul lagi. Okay, theta ni dia akan unitless. So dia boleh in term of flow, dia boleh in term of concentration, dia boleh in term of fraction. Okay, alright. Ni concentration, sorry. So this one, alright, F, okay, F is equals to CA times with this one, volumetric flow rate. Okay, that's why you have this one. Okay, so Fi naught, okay, is equal to Ci naught times V naught. Alright, then we have a F A naught, C A naught, V naught. Okay, kena adjust lah. Kalau ni at any time, dia akan jadi di sini. Kalau T0, sini 0. Okay, so daripada situ, you boleh sebenarnya cancelkan. Kalau you nampak, kalau V naught dia dah bersama, okay, so you boleh cancelkan. Okay, that's why you akan jadi CI naught over CA naught. Alright. Okay, so basically inilah yang nak diterangkan. Okay, so we have a flow system here. Okay, so this is batch system. Okay, kita recall balik mana saya punya ni pen. Ni batch system. Okay, ini kita dah belajar dah. You dah pro lah. Exempted lah ni. Alright, and then we have a flow system. Okay, sekarang ni kita nak concentrate pada flow system. Okay. So CA is equal to FA, mana saya punya ni, FA over V is equal to FA naught over V 1 over X. Okay. So kalau you dah tahu ini, you dah tak ada problem sebab you akan kaitkan CA tu dengan flow rate ni lah. Okay, so just tukarkan je. So remember kita ada CA is equal to NA over V and juga FA over V this one. Okay, so gantikan sahaja. Okay, so this one F and naught 1 over V sama je, lebih kurang macam ni. Cuma you gantikan dia instead of N jadi F. And this one jadi volumetric flow rate. Okay, faham tak semua?
Faham, Doktor.
Okay, alhamdulillah faham. Okay, so let's say kita ada if, alright, V is equals to V naught. Okay, kenapa kita dapat ini balik? Okay, mai I cerita. So sekarang if V, volumetric ni adalah CA is equal to FA. Ni kan? Alright, so equals to FA naught, alright, over with the, alright, 1 minus with the X. Okay, Allah bagi teruk tulisan. So automatically this one kita ada cancel kan? So kita boleh dapat CA0 1 minus X. Okay, itu untuk case kalau volumetric flow rate dia sama. Tapi kalau volumetric dia tak sama, you tak boleh buat directly macam tu. Okay, you kena ada CA, yang ni kita akan belajar lepas ni, FA over V is equals to FA0 V, alright, V naught, alright, ni panjang sikit, 1 minus X, dia akan tambah 1 plus EX, okay, whereby V yang at any time, at any T, dia akan jadi 1 plus EX V naught, okay, so this one is not applicable for volumetric yang constant, okay, ni kalau tak constant, you kena ada epsilon, alright, okay, faham? Okay. Alright, selalunya kalau senyap ni orang Melayu kata tanda setuju. So saya kalau senyap ni saya bermaksud awak faham lah kot. Alright. Okay, so we have here this one, feed and change. Okay, ni macam Stockholm Table tapi for a flow system. Okay, so ni flow ni adalah sebenarnya feed dengan change. Okay, remember kita akan tengok pada ni kan. Alright, so FA naught is minus FA naught X, so kita dapat FA. Alright, so this one is about minus B over A, alright, FA naught X. Okay, so this one would be FB, okay, is equal to FB naught, alright, minus B over A, FA naught X. Okay. So this one remember theta B boleh jadi F B naught over with the F A naught here. Okay, so boleh jadilah kita dapat theta B, okay, minus B over X. Ini ini nanti I terangkan lah. Okay, so and then here we have a F C naught, okay, is equals to theta C F A naught. Alright, this one should be plus C over A. Okay, FA naught X. Okay, then we have another one which is FD naught. Alright, is equal to theta D FA naught. Alright. Okay, and then this one is D over A FA A not X. Okay, ini sebenarnya I dah letak kat luar. Okay, which means that, okay, contohnya this one is FC, alright, which is FA not, alright, which is theta C plus with the CA, alright, time X, alright. Inilah benda dia, saya dah letak ni luar. Okay, yang ni saya darabkan dia terus, that's why awak nampak kat sini. Okay, sebenarnya kat sini ikut awak lah kan, sama ada awak nak letak ni theta C sahaja ke dulu pun tak apa, ikutlah mana. Tapi yang penting yang ni kena dapat betul lah. Alright, and then we have a FD here, alright, we have a FA not, alright, and then we have a theta D plus with the D over A times with the X. Okay, sama juga macam yang buat tadi, which is contohnya N tadi, N A not, this one is ND, alright, is equal to theta D plus with the D over AX. Dia sama je, cuma you tukar F dia. Okay? Inilah dia punya ni. Okay, so sekarang ni dia agak mencabar bila dia berlakunya dekat variable volumetric flow rate. Okay, bila ada variable volumetric flow rate, you kena consider ni lah, ada P dengan T semua ni. Alright? Okay, okay, so far okay ke tak? P dengan, F dengan N dah okey kan? Cuma kita yang part ni lah agak sikit belum lagi you boleh faham sepenuhnya, betul tak?
Betul doktor.
Okey. Tak apa, sekarang pukul berapa? 11.30. Kita try sikit lagi lah. Kita try sikit lagi beberapa few ni. Okay. Alright, sebab kita macam terlalu sangat pack jadual sebab kebetulan ada minggu depan ada cuti kan, Khamis di Pawali. Okay, so to derive the concentration of the species in term of conversion for a variable volume flow system, we shall use the relationship for the total concentration. Okay, sekarang ni adalah variable volume flow system. Okay, tadi kita assume yang kita belajar tadi adalah constant volume flow system. Okay, sekarang dia dah berbeza. Okay, so the total concentration at any point in the reactor would be CT FT over V P Z RT. Okay, sebab asalnya kan PV and RT kan, kalau basically lah. Alright, so sebenarnya kita boleh dapat concentration daripada N over V, betul tak? So N over V equals to P P O
Doktor, lag balik.
RT. So this adalah concentration. Okay, so far saya cakap ni ada lagging lagi ke?
Sekarang okey. Kot. Cik doktor cakap.
Okay, so saya ulang 3-39
Okey boleh.
Okay, so sekarang ni tadi kita tengok adalah constant volume flow system. Okay, sekarang ni adalah variable. Okay, so bila variable, okay, macam mana kita dapat this equation? Alright, yang kita kaitkan PV and RT. So PV is equal to nRT. Okay. mole over liter, number of and okay, so from here, jap. Am I sharing this screen or not? Oh, okay. Alright, so daripada situ what you need to T equal to 0, okay, in order for you to equate P